Okay, I was trying to check grades right before class started, but alas, I thought I'd be able to do it on my phone, but it was taking a while to log in, and I just want to go ahead and get started. We only have two homework assignments that are outstanding. I'm not sure what the status was, at least as of yesterday. Both 3.4 and 4 were still being graded. I'm not sure if the TA got a chance to look at them between now and when class started. But the solution is available for both of them. So, and again, we have no outstanding assignments or anything assigned, and nothing will be assigned until Wednesday due Friday. Okay, so you have no homework assignments now. Okay, the only thing that is outstanding on your desk right now is the project. Okay, but that's not due until the middle of October. So for all intents and purposes, the only thing I want you worried about right now is the celebration on Monday. Okay. Let's see. Oh, before we go into that, just wanted to mention that next Wednesday, the career fair is from 12 to 4 in the rec center, if anybody is interested in going. Okay. Also, on exam review day, I just make sure that everybody is cognizant of the grade distribution, because folks always tend to think about that right around now. Each exam's worth 20% in here. So that's the grade distribution. All right. Did everybody get the code? Okay. So if you've had me for class before, you know that what I tend to do on exam review day is I spend the first few minutes going through the logistics of the exam and what to expect, and then the rest is up to you in terms of what questions to go through. If you have anything you want to discuss, anything you want to do, that's what I'm here for. Okay. So let's go through the logistics. Let's make sure everybody's aware of what's up. Okay. Let's see. So you, well, first off, let's talk about the format of the exam. It's going to be comprised of 4 to 5 really short questions and 2 to 3 longer questions, I guess you could say. No more than that. The exam is not intended to be time critical. I did the exam. Okay. I did the exam. I took it. And I was able to do the exam and develop a neat solution. I timed it in 17 minutes, okay? So if I'm able to do the exam in 17 minutes times 3, you should be able to do it in 50 minutes, 51 minutes. And I'm actually going to give you 55 minutes because I'm going to give you until 10:55. So you should have more than enough time. It's closed book, closed notes, but I am going to allow you to bring a formula sheet. I'll say that a straight edge might not hurt. It will definitely help during exam 2 and 3. It may not a bad idea to go ahead and bring a ruler, a scale, something like that, but it's not absolutely necessary. On exam 2 and 3, though, it will help. In terms of the formula sheet, the one big thing I really want to caution against is putting fully worked out example problems. That is not me trying to be difficult. It's really more for your benefit. I have had a number of instances in the past where there'll be like a Truss analysis on the exam, and then suddenly numbers from the formula sheet find their way onto the joint analysis that you're doing on the exam, and now the joint analysis doesn't make any sense. Okay, so what I would say is steer away from doing like fully worked out example problems. I don't have a problem with snippets or things like that. But I would just steer away from that. The big thing, though, that's really most important to me is that the formula sheet needs to be prepared by you, okay? What I don't want to see is just, here's the slides, let's copy and paste them, scale them down to an 8.5 by 11 double-sided and hit print, okay? Yeah, you could do that in about 5 minutes, but I'm a believer that making the formula sheet is studying, okay? And so by going through the exercise of crafting it yourself and taking your thoughts and organizing them into a formula sheet, I think is valuable. And I'll tell you this, the formula sheets in this class do tend to be pretty thin in content because, I mean, how many formulas have we discussed this entire semester? Like 6? You know what I mean? I mean, I'm actually serious when I say 6. I can only think of really 6 true formulas. I can think of, you know, some forces in the x direction, some forces in the y direction, some moments. I can think of the two I formulas, the I sub E and the I sub T, and deflections. I'm like, that's it, you know? So maybe that and, you know, centroids of triangles. That's about it, you know? So there's not really a whole lot in the way of that in this class. I bet that probably surprised you in a junior level engineering class if there aren't any formulas. It's kind of strange, isn't it? Okay, let's talk about what's covered on the exam. I will say that I am not one to start throwing stuff on an exam that you've never seen, okay? This is lecture 14. The exam covers everything from lectures 1 to lecture 12, okay? Lecture 13 was the analysis project, so that's not really on the exam. So if we discussed it in those 12 lectures, or if it was in an example problem or in a related homework assignment, it's fair game. Anything else, like I'm not going to ask you to draw a shear and moment diagram on the exam. Granted, I know you've seen that before, but we haven't talked about it in here. That's not the point. Our exam is really going to be focused on these topics: stability and indeterminacy, being able to compute support reactions, being able to analyze a truss, and being able to compute deflections in trusses. And in terms of the topics, here it is. So for stability and indeterminacy, make sure that you can classify a structure. And so by that, I want to know whether or not a structure is unstable. I want to know whether or not it is stable and statically determinate. And I want to know whether it's stable and statically indeterminate. And if it's indeterminate, I want to know the degree of indeterminacy. I want to know that it's indeterminate to the 6th degree, or to the 2nd degree, or to the 4th degree. Okay? I want to know what that degree is. For support reactions, I want you to be able to compute support reactions for statically determinate structures. I'm not going to give you an indeterminate structure. I want to be able to do that when subjected to concentrated forces, concentrated moments, distributed loads. That's both uniformly distributed loads and triangular loads. I want you to be able to deal with pin supports, roller supports, fixed supports, and I want you to be able to deal with internal hinges. For trusses, I want you to be able to analyze a truss. In other words, I want you to be able to determine the internal member forces in trusses using the method of joints or the method of sections, whichever one works. And deflections. I want you to be able to analyze real and virtual trusses and compute associated deflections. That's what I want you to be able to do. That is the coverage on the first exam. The rest of this slideshow is meant to be the greatest hits over the past 12 lectures for the purposes of assisting you in crafting a formula sheet. So for example, the degree of external indeterminacy. So I sub E. Remember, these I formulas are just comparing the number of unknowns in a system to the number of knowns. In the case of the external stability, the unknowns are the reactions. The knowns are the number of equations of condition plus 3. Why plus 3? Because we have 3 equations of equilibrium, and the equations of conditions are things like for every internal hinge or whatnot that's in the system. Remember, if I is negative, the structure is stable, or unstable. If I is non-negative, the structure should be stable. Okay? And remember what does the whole should be mean? Well, the reactions cannot all be concurrent and they cannot all be parallel. Okay? So if that's the case, it doesn't matter what I is, the structure is unstable. Okay? Make sense? Then we have the internal indeterminacy of trusses. We have M plus R minus 2J. M plus R are our unknowns. We have the unknown reactions, and then one unknown for every member, because every member only contains one unknown force, it's either a compression or tension, but it's only one value. For every joint, however, there are 2 known equations of equilibrium. Okay, so M plus R minus 2J. And the same thing that these non-negative values of I don't guarantee internal stability. Internal stability for trusses happens when the truss is externally stable or when it's constrained against rigid body movements. And I'll go ahead and tell you right now, I am not going to try and trick you on this. Okay, I'm not trying to do that on the exam, so don't worry about that. Okay. In other words, if a truss is unstable, you're going to know. Okay. All right, support conditions. We have 3 support conditions that we've been dealing with this semester: pin supports, roller supports, fixed supports. Keep in mind the rollers can be inclined. When we're dealing with distributed loads, these are the only 2 that we've dealt with, and I'm not going to throw some, parabolic load or sinusoidal load. I'm not doing that, so don't worry about that. It'll be one of these. Remember, we can collapse a uniformly distributed load into a point load at the middle, and a triangular load, we collapse that into a point load a third away from the largest magnitude. Don't forget that when you collapse a triangular load, the magnitude is WL over 2 because it's a triangle. Okay, so don't forget the 1/2. That 1/2 is very easy to forget. I've had a lot of students forget to throw the 1/2 on there, so don't forget that. Incline loads. Don't forget that an incline load is split up into its X and Y components. You can do that either with the slope ratio or with an angle. In most civil engineering applications, I have found that inclinations tend to be expressed with slope ratios. Like roofs are on a 4/12 pitch or what have you. So slope ratios tend to be how they are expressed. And by the way, this presentation is on Blackboard, so if there's anything you missed, it's there. For inclined rollers, we can do the same thing. Just remember the slope ratio flips because we're dealing with a perpendicular line. The line of action of the reaction is perpendicular to the slope of the ground. So for example, if the ground is 12 over and 5 up, this is 5 over and 12 up for the reaction. So that's why the vertical component is 12 over 13, horizontal component is 5 over 13. Let's see. When you're cutting a section, when you cut a section through an arbitrary point in a structure, you have at most 3 internal unknown forces, but when you cut a section through a hinge, you only have 2 unknown force components because the internal moments at a hinge are 0. So if you cut a section through a hinge and look at one side of the structure or the other, you can sum moments at that hinge looking at that sort of left half or right half of the structure, looking at that free body diagram, and you can rest assured that the internal moments there are 0. And for trusses, we have 2 analysis methods. We have the method of joints or the method of sections. When we deal with the method of joints, keep in mind that we are summing, we are dealing with a situation where all the forces all meet at a common point. So we can only sum forces in the X direction and some forces in the Y direction when analyzing a joint. We don't have moments at a joint because there's no non-concurrent forces. So with that, we can only solve a joint with at most 2 unknown forces. So whenever you're doing a joint analysis, keep in mind that keep in mind that you can only deal with 2 unknowns at the same time. Probably not a bad idea on a truss problem to maybe, if you have to solve the entire truss, chart out which joints you need to solve in which order to make your life a little easier. Method of sections will give you that third equation of equilibrium, so you can cut a section through 3 unknown member forces or unknown members. But you have to do a little bit more drawing. The value of the method of sections, though, is that if you're only interested in the force in one member in a truss and it's in the middle of having to solve 8 or 9 joints, you can solve the problem pretty quickly utilizing the method of sections. 0 force members. It's not a bad strategy to be able to identify 0 force members. Remember the 3 rules that we used were: 1, if you have a joint where there's no loads, if you have 2 members framing through a joint, it's got to be 2 members framing through the joint, and there's no external loads applied to the joint, then both of those 2 members are 0. Now that does also work in cases like this where you've got 4 members framing in, but only if you've already determined that 2 of those are 0. There's got to be 2 true unknowns, and there has to be no external loads applied to the joint. If that's the case, both of those are 0. If you have a case where you have 2 members and you do have a load, but the load is collinear with one of the members, then the other member is a 0 force member. Same thing applies if you have multiple other members turning in, but these are already determined to be 0. And finally, if you got a joint with 3 members, no loads applied, and 2 of the members are collinear, these 2 carry the same amount of load, and that's a 0 force member, okay? And we did have an exercise where we went through and practiced these on a somewhat odd truss, but we were able to identify some 0 force members pretty easily. And last but certainly not least, virtual work. So whenever we're assessing virtual work, we look at both the real structure and the virtual structure. The virtual structure is taking all the loads off and just placing a single unit load at the point of interest with a magnitude of 1 in the direction of the assumed displacement. So we solved the real truss, solved the virtual truss, plug and shove. Very tabular expression. And if you need to do any tabular computations, I will provide a table for you because it takes a while to draw that out. This is not a table drawing test, okay? So I'm gonna save you time there, okay? Does that make sense? Okay, that is the exam. You have the rest of class to ask me whatever is on your mind. And my goal is, if you are nervous about the exam on Monday, to make you not nervous about the exam on Monday. So anything that's on your mind, floor is yours. Yeah.
Will there be any definitions, or are they just like calculations?
Will there be any definitions? Maybe, but if there are, they will be very minimal. I mean, this is a structural analysis test. What I can tell you, here, let me answer it this way. I gave a statics exam last week, and there were terminology-based questions on that exam, but out of a 100-point exam, each of those questions was maybe worth 4 points. So very, very minimal. The star of the show is the computations. How many of you are nervous about the exam? And if so, why? I'm curious. Anybody nervous about the exam? Well, that's good. I'm happy about that. Is it just Friday? And you're just like, I'm done.
This exam, it's a Sunday issue.
This is a Sunday issue. This is a Monday 9 a.m. issue.
Yeah, I mean, obviously.
I know things about stuff.
Obviously, Sunday rolls into Monday, but yeah.
Sunday and Monday blur together.
Oh, they blur together. Yeah.
There's a blur. There's
Yeah, there's a blur.
There's a blur. There's a fuzziness. There's a Venn diagram there. There's a Venn diagram, or is it just one circle? I know things. Any particular homework problem that was tricky? Any in-class topic? Anything that you want me to go back over? You name it. How many of you came in and was like, oh, I was supposed to come up with questions and I forgot to come up with them prior to class? At least he shook his head yes, so I appreciate the honesty. Be straight with me. For how many of you in this room is this your last class of the day? And you're just like, I'm done.
You wish. You wish.
What's that? You got another one?
Yeah, we all got fluids.
Oh, yeah. Oh, that's at 1 o'clock, right? That is the high pressure environment.
You don't.
That exam is on Wednesday.
Did you get it? Because I said high pressure. Gravity? What's so specific about it? Sorry.
Dr. Buck, I really don't know. No idea.
That was a joke. I heard from
I don't really even know what that guy's equation is supposed to be used for. Yeah.
You just got to gotta go with the flow in there, okay? You just gotta. We have a structural analysis exam review session. I spend the whole time making fluids jokes. Okay, this is your time, but I am not going to extend this any longer than it needs to be. If this class truly doesn't have any questions, we can end this early, but I don't want to do that if there are questions, okay? So, here's how we'll do this. Going once, going twice. I will see you Monday at 10 a.m.
Exactly.